All right, you guys. It's December 7th. Wow, a day that will live in infamy. Anyway, you guys look it up. It's my generation's 9/11, but you have to look it up. It has to do with Pearl Harbor, maybe. So anyway, here we are. We're talking about things called rational expressions. Okay, and with rational expressions, it's a fancy word for fractions. Anything, a fraction is just a rational number. Okay, that's the word. Rational means fraction. So what we want to do today is make sure that we simplify these today. So we're going to simplify rational expressions. Now before we start though, we know that dividing by 0 is bad, okay? So we saw that. Cookie Monster told us how bad it was. We know that if you divide by 0, you get a bad thing, all right? You get an asymptote, don't you? Anything divided by 0 is a bad thing. Don't do it, okay? So if we take a look on example 1, dividing by 0, make Cookie Monster sad. If you look at example 1, what are the values that are excluded values of x? Excluded values, which means there's some things x cannot be. So if we don't want to divide by 0, and those are going to be my excluded values, okay? Those are the ones that divide by 0. When you divide by 0, you can't, so you have to get rid of them. You exclude them. So to do number 1, I'm going to factor. I'm going to go back to factoring so I can see this problem a little bit better. So I'll factor the numerator. So I'll rewrite this as f of x equals, I'm going to factor this into x plus 3, x minus 2, right? I'm going to factor the denominator into an x plus 4 and an x minus 2, okay? Now, don't cancel these. It's tempting, but don't, because it's a totally different problem. So here's what we know. Excluded values, okay? Don't divide by 0, right? So right here, if x were 2, we'd be in trouble. If x were 2, so if x equaled 2, we'd have 2 minus 2 is 0. We divide by 0, so let's make sure x does not equal 2, okay? And right here, if x is going to be 4, negative 4, if x is negative 4, we'd have negative 4 plus 4 is 0. Can't happen. We divide by 0. Bad news. So we cannot divide by negative 4, okay? So those are my excluded values. So the domain then is everything else. Don't worry about the top because those are going to be zeros. We'll talk about those later, okay? But what's the domain? So the domain is everything. Domain is x equals all real numbers except x cannot equal 2 and negative 4. So x can be anything except for negative 4 and 2, okay? All right, example 2. So in example 2, what we're doing is really looking at reducing fractions. So I took a really simple, easy example, okay? 4/12, hopefully you'd say, no, Mr. Davies, can't be 4/12. It is really going to be 1/3, right? Because I had a 4, and this is like 4 times a 3, and you cancel the 4s and get a 1/3, right? Well, in example 2, we're going to do the same thing. What we want to do is simplify it, okay? Before I start, though, excluded values, x cannot equal 0, because if x is 0, we're in trouble, right? But to do this one, I'm going to factor, like I did above. So let's see. I'm going to common factor. So both of these have a common multiple of 2 in common in the numerator. And they both have at least an x squared in common. Okay? So if I common factor out a 2x squared, I would have inside remaining an x minus 4. And of course the denominator, I can't do anything with the denominator, it's still a 6x squared. Now I want to simplify it. I want to go ahead and reduce it, just like we reduced 4/12. And I reduce the 4s, and reduce this. So I do know the x squared cancels with the x squared. I like that. And 2 over 6 makes 1/3. So a simplified or a reduced answer would be 1 x minus 4 over 3 because I reduced my 2/6 into 1/3. You don't need the 1, but there it is. Okay, example 2. Well, first of all, if I need the excluded values, let's go ahead and factor. So I'm going to factor, let's see. I'm going to factor this into an x minus 4 and an x minus 1, right? Negative 4 times negative 1 makes a positive 4, but they add together make a negative 5. In the denominator, we're going to factor this into an x minus 1, right? And then what I can do is I can reduce this. But before I do that, what are the excluded values? Well, first of all, x cannot equal 1. And again, x cannot equal 1. I don't really need to write it twice, but I did. Okay, so now let's reduce it. I love this part because cancel, cancel, right? Anything on top with anything on the bottom just cancels. And then I'm left with an x minus 4 over an x minus 1. There's my answer. X better not equal 1, otherwise you divide by 0 and you make Cookie Monster sad. Okay, let's take a look at the next one. Example 4. On example 4, we're going to go and we're going to talk about multiplying fractions. See this multiplication here? Well, let's go back to a basic problem. Back to 6th grade math. I've got 3/5 times 10/9. So one way to do it is multiply straight across. 3 times 10 is 30. 5 times 9 is 45. Okay, that is correct. But I like to cross simplify first. Let me write this up here. Cross simplify or cross reduce, even better. Let's cross reduce first. Well, 5 and 10. 5 goes into 10. They both divide by 5. I'm left with a 1. I'll grab a different color. Where's that? Where's that blue? Here it is. Okay, 5 and 10. I'm left with a 1 and a 2, right? 10 over 5. And the same thing here. I could cross reduce my 3 and my 9. Reduce 3, 9. I can get a 1 and a 3. Now if I multiply straight across, it's much easier. 1 times 2 is 2, and 1 times 3 is 3. Okay, so that's 6th grade math. What about example 4? Well, we can do the same thing. Before we do anything, let's go ahead and first factor. Okay, because if we factor, we get it into something much easier. Okay, so all right, let's just do this. And parentheses, right? I'm going to go in x minus 3, x plus 1, right? I'm going to go in multiples, make negative 3, and I add them together and get a negative 2, okay? The denominator is just going to be an x plus 1 and an x minus 1, okay? We will practice factoring. When we are live in Zoom, we will practice factoring. Number 2, let's see, second part of this fraction, I shouldn't say number 2, but second part of this fraction I'm going to factor it into, it's got to be a, let's see, a 7 and a 9 probably, x minus 9 and x plus 7. And then I'm going to factor the second fraction, its denominator, probably a 7 and a 3, probably an x plus 7 and an x minus 3, because that will multiply to make negative 21 and add to make 4. Now, here's the fun part. We're going to cancel, right? Excluded values real quickly. X cannot equal 1. X cannot equal negative 1. X cannot equal negative 7. X cannot equal 3, right? Those are my excluded values. But here comes the fun part. Let's cancel, right? Anything on the top. Anything on the top. So this x plus 7 cancels x plus 7, right? Anything on the top. This x minus 3 cancels x minus 3, okay? So, oh, we got more. X plus 1 cancels x plus 1. Oh, I like it. So this thing really reduced down significantly into an x minus 9 over an x minus 1. Okay, there's your answer. It reduced. We multiplied and we reduced, okay? All right, now, last but not least, number 5. So we divide. Divide is just like multiply, except for you have to flip, or we call it invert and multiply. We're going to flip the second one. Flip the second one. Always flip the second one, never the first one. So we flip the second one and then multiply. So we learned this in 6th grade math. So here we go. Rewrite this as 3/4 times 16/9. And again, I could multiply straight across, but I'm going to reduce first. Just like I'll do the same thing here, I'll reduce. So let's reduce. Cross reduce. So 4 and 16 is going to make a 1 and a 4, right? And a 3 and a 9 is going to make a 1 and a 3. And now if I multiply straight across, it's so much easier. I get 1 times 4 is 4. 1 times 3 is 3. And I get 4/3. Boom. Got it. Okay, now let's do the same process over here in example 5. So for example 5, before I do anything, let's first factor. Okay, so I'm going to go ahead and factor the numerator of the first fraction, x plus 5, x minus 3, right? Let's factor the denominator of the first fraction. How about an 8 and a 5? How about an x minus 8 and an x plus 5? Okay, let's look at the second fraction. Let's factor its numerator. How about an x? How about a positive 9, negative 1? X plus 9, x minus 1. And then we'll factor the denominator of this one. How about a 8 and a 9? How about an x minus 8 and an x plus 9? Okay, now flip the second one. So we're going to rewrite this, but I'm going to rewrite it as already factored. So let's see, I'm going to flip the second one. So I'm going to flip this one. X minus 8, x plus 9 over x plus 9 times x minus 1. So flip the second fraction. So I just flipped this one. Let me highlight it. See it? Okay, just flipped this one. Okay, I flipped the second fraction. There it is. I flipped it. Let's change it to multiply because that's how we did fractions in 6th grade. So I put the don't flip the first one. Keep the first one the same. First fraction does not flip, right? Does not flip. X plus 5, x minus 3 over my x minus 8 and my x plus 5. Okay, now anything on the top cancels with anything on the bottom because you're just reducing. So let's see what can I cancel. Oh, x minus 8 with x minus 8. Boom. X plus 5 with an x plus 5. Boom. X plus 9 with an x plus 9. Boom. Yeah, you could have canceled actually back over here. You could have done that, but that's okay. And I guess you could have canceled here. Boom, that would have made it faster, but that's okay. I'm trying to show this the way to do it. So what's left over? An x minus 3 over an x minus 1. X better not equal 1. Okay, there you go. So we've got homework for you, and it's on reducing, on multiplying, and dividing. Don't forget to flip when you divide. And that's all I have. We'll zoom and we'll talk more about this.